Hello guys, so welcome to our channel Row and Basic. So this time we will learn how to solve for your intercepts and zeros of exponential functions. But before that, let us first review your laws of exponents. So we have here some basic laws of exponent, and first let us try to discuss this one. So we have first the product rule, or we are just multiplying quantities with different exponents but with the same base. Okay, such as example, we have a times 2, or a raised to 2 times a raised to 3 is equal to a raised to 5. So if the bases of the quantities are the same, we are adding the exponents. Okay? Basic. Such as another one, we have ab squared times a cubed. That will give us a raised to 4b squared. So the exponent of a in here is 1, and a has an exponent of 3, so we have 1 plus 3 is equals to 4, then copy b squared. So it is just a review. Let us proceed to number 2. Under your product rule, we have the distribution property of exponents, or it is like multiplying quantities with different bases but the same exponents. Or if we will try to start with this one, we have a times b raised to x is equals to a raised to x times b raised to x. We are just distributing the exponents on the quantity inside. Okay? Such as this one, we have example, we have a squared times b squared is equals to a b squared. Okay? Then number 3, we have a raised to x raised to y is equal to a raised to x times y, or it is known as the power raised to another power, or the power rule of the exponents. So example, we have a raised to 2 raised to 3 is equal to a raised to 6. Okay? For example, we have a raised to 2 raised to x, that is a raised to 2x. So a power raised to another power, we have to multiply the exponent to the other exponent. Now let us go to the quotient rule number 5. We have here a over x divided by a over x divided by a over y, and that is equal to a x minus y. So again, quotients and products, or multiplication and division, are the inverse. Okay? So in getting the product of numbers or quantities with the same bases but different exponents, we are adding the exponent if we are multiplying, and when we are dividing, we are subtracting the exponent. Again, the product rule, we are adding, or when we are multiplying quantities in relation to exponents, we are adding the exponents, while if we are dividing, we are subtracting the exponents. So such as example, we have a raised to 5 divided by a raised to 3, and that will give us a squared. Okay, so the denominator will be disregarded because the greater value is on the numerator. So I'll give you example with this one. A squared divided by a raised to 4. That will give you 1 over a squared. Okay? So a squared will be written on your denominator. Okay, so another example, I will give you this one. Example, we have a squared b cubed over b raised to 5. And using your quotient rule, it will be a squared over b squared. Okay, so we have 5 minus 3. Okay, 5 minus 3, but 5 is below. Okay, if we will try to write it using your numerator alone, we will have this one. A squared times b raised to negative 2. So to make this positive, we will write it on your denominator. Okay? So I guess we are clear in that. Again, this is just a review. Number 5, we have a over b raised to x, or this is the distribution property of exponents over division. This one is a distribution property over multiplication. So here we are dividing exponents with different bases but the same exponents. Okay? So it's just like we are distributing your exponent on the numerator and the denominator. So example, we have 2/3, or let's start with this one. We have a over b squared. That will give you a squared over b squared. Or example, we have 3/4 raised to 2. So we will get 3 squared over 4 squared. Okay? So that is how to apply your rule number 5 for your law of exponent. So let's proceed to number 6. A very basic rule. Any number raised to 0 is equal to 1. But a should not be equal to 0. Again, any number raised to 0 is equal to 1. Where a is not equal to 0 because 0 raised to 0 is 0. So this is the limitation of the rule number 6. Any number raised to 0 is equal to 1. 1 raised to 0 is 1. 1 million raised to 0 is 1. Okay, negative square root of 1 million is equal to 1. Or sorry, not square root, but again, any number raised to 0 is equal to 1, but 0 raised to 0 is equal to 0. Okay? Then we have the negative exponents. So example, we have a raised to negative x, and that will become 1 over a raised to x. Or one example is this one. We have a squared b raised to negative 3. That is b squared over b cubed. Okay, so this negative exponent will become positive if we will put it on the denominator. Okay? Let's proceed to the last law of exponent. We have fractional exponent. So we have a raised to 1 over x is equals to the square root of a, and the index is the x root of a. Or shall we say we have a raised to 1/2. That is equal to square root of a. So 2 is written in here and 1 is written in here. But the lowest root that we are using is 2. So 2 is should not be written. It will be understood that we have 2 in here if we are using square root. Okay? So another example is a raised to 1/3. So that will be the cube root of a raised to 1, or 1 will not be written. Okay? Then another thing, we have a raised to y over x equals the x root of a raised to y. So example we have a raised to 2/3, and that will become a inside. The denominator is in the index, and this one. Okay? So you have a raised to 2/3 is equal to the third root of a squared, or the cube root of a squared. Okay? Okay, last example we have b raised to 3/4. And that will be equal to, b is on the inside the radical symbol, 4 is on the index, and b will be written here. Okay, so that is just a review of the laws of exponents, and we will now proceed to computing your intercepts and zeros of exponential functions. On the board, we have here f of x equals to 3 raised to x, and we have to determine the x and y-intercept. Okay, so again, our lesson is all about the intercepts and zeros of exponential functions. Okay. So, the basic concept in solving your x and y-intercept. Okay, let us first solve for the x-intercept. The x-intercept. So, when we are solving the x-intercept, y should be equal to 0. Okay, so if you can see, we have f of x equals to 3 raised to x. So, where is y on our given exponential function? So there is no y in here. So we can write it in y form as y is equal to f of x. Okay, so therefore y is equal to 3 raised to x. Okay, now let us proceed. So let y become 0, and that is 0 equals to 3 raised to x. Okay? Now, can we solve this one? 0 is equal to 3 raised to x. So we cannot solve it further. So therefore, we can say that the equation has no 0. The equation or the function has no 0, or we can say that 0 or no x-intercept. Okay, so when we are talking of zeros, we are talking of x-intercept. So it is just known as 0 of your exponential function or equation because we are equating your equation to 0. Okay? Again, x-intercept is the 0 of the function or your equation. So again, it is known as the 0 of the function because we are equating your equation or whole equation to 0. Okay? Now let us proceed to computing your y-intercept. Okay, for your y-intercept, we have x equal to 0. So we have y equals to 3 raised to x. Let us substitute x to 0. So we have 3 raised to 0. Law of exponent, any number raised to 0 is equal to 1. So therefore, our y-intercept is at y equal to 1, or shall we say that the y-intercept is at 0 and 1. So y-intercept is the point of intersection of the graph of your exponential function on the y-axis, while x-intercept is the point where your exponential function intersect with your x-axis. So I will give you an overview of the graph of this exponential function. So maybe not the exact graph, but I will give you a hint how this thing goes. Okay, so the y-intercept is at 1. So this is 1, 2, 3, 4, -1, -2, -3. Assuming we have 1, 2, 3, 4, -1, -2, -3, and -4. Okay? I will give you the characteristic of the exponential function in the form of this one. Y is equal to b raised to x. In general, the form of your exponential function is a raised to b x plus c plus d. Okay? So a is the initial point, or in the application is the initial population, or again the initial point. So in this form, your initial point is 1, and d is 0, and c is also 0. That is why what's left is b raised to x. Okay? What's left again is b raised to x. And an exponential function in the form of y equals to b raised to x, where the initial value is 1, and the constant of your exponent is 0, and b here is 0. And we will discuss the whole thing later. So therefore, what you mean is b raised to x. And in that case, the graph will look like this. Okay? Example, we have y is equal to 3 raised to x. The graph is just like this one. And the x-axis will be the asymptote, or the horizontal asymptote. That is why the graph cannot pass your x-axis. And therefore, there will be no x-intercept. Again, in the form of y is equals to b raised to x, such as the exponential equation y equals to 3 raised to x, this one. Your initial value, again, a, is always 1. And there will be no x-intercept because your x-axis is your horizontal asymptote, and therefore the graph cannot intersect your x-axis. So therefore there's no x-intercept. So another example is y equal to 2x. The graph will still look like this. Okay? Y is equal to 4 raised to x, y is equal to 5 raised to x, y is equals to 10 raised to x. Still the graph will pass in that thing. Still 1. Okay, the y-intercept is still at 0, 1. The point in here. Okay? As long as it is in the form of y is equal to b raised to x. Okay? Let's proceed to another example. Assuming you have an exponential function y equals to 4 raised to x plus 1 minus 2. So let us solve for the x and y-intercept. Solving first your x-intercept. Again, x-intercept, y is equal to 0. So copying, we have y equals to 4 raised to x plus 1 over 2, minus 2. Then substitute y equal to 0, and that will become 4 raised to x plus 1 minus 2. Okay, combining like terms, we have positive 2 equals to 4 raised to x plus 1. Where did we get your positive 2? Okay, and here. So positive 2 is transferred using transposition, but again, transposition is not an operation. So we have the addition property. So we added 2 in here to eliminate negative 2. Therefore, we will add 2 on the other side to make it balance. So negative 2 will be eliminated. And we have plus 2. 0 plus 2 is 2. Then we have 2 is equal to 4 raised to x plus 1. Okay, using the property of exponential equality or exponential function, we have to make the bases equal. So 2 raised to 1 is 2 and 2 raised to 2 is 4. Okay, are we clear on this? Then copy x plus 1. Okay, simplifying, we get 2 raised to 1 equals to 2 raised to 2 x plus 1. And here, so we are now on the same basis. We will disregard the basis and solve the exponents. Solving the exponents, we have 1 equals 2 times the quantity of x plus 1. Then solving, we have to distribute 2 times x, then 2 times 1. Okay? Again, combining like terms, we get equals in here, copy 2x. So we will isolate x on the other side. It's either you will isolate it on the left side or the right side. For me, I will isolate it on this side. So we have to subtract 2 in here to eliminate. So we have to subtract 2 in here. So we are now so we subtracted 2 in here. So let's subtract 2 on the other side. So we have 1 minus 2 equals to 2x. Positive 2 is eliminated on the other side, so we have now negative 1 equals 2 raised to x. 2x, I mean. Simplifying, we get divide 2 on both sides to eliminate this 2. So we have now x is equal to negative 1/2. Or proper way of writing it is x is equal to negative 1/2. For your x-intercept is at point negative 1/2, and 0. So it's either you will put your negative sign on the numerator, or it's either you will put your negative sign on the numerator or at the center of the fraction or aligned in the fraction bar. Okay? You cannot put it on your denominator. Just like 1. So ugly. Okay? Positive divided by negative is negative. That is why it's not written on the denominator. Okay? Now let us go to your y-intercept. Okay, solving your y-intercept, x should be equal to 0. Then copying your function y equals to 4 raised to x plus 1 minus 2. So x is equal to 0. We have y equal to 4. Substituting x 0. Then we have y equals to 4 raised to 0 plus 1. We have 4 raised to 1 minus 2. Then we have 4 raised to 1 is 4 minus 2. So therefore we have 4 minus 2 is 2, of course. Then we can say that the y-intercept is at point x0 and y is equal to. Okay? We have the graph. It's like this one. So your y-intercept is at 2. Example, this is 1 and 2. Your x-intercept is at, example, this is negative 1, negative 2. So this is negative 1/2. So the graph will pass in here. Just like that. And I will give you a hint. The constant here, the constant negative 2 is your asymptote. Okay? So this is negative 2 and this is negative 1. Okay? I guess that we are clear on this example. Okay, let's have another one. Okay, for the next example, we have y equals to 3.2 raised to x plus 8. Again, 3.2 raised to x plus 8. Okay, first let us solve for the x-intercept. Again, solving your x-intercept, you will put your y equals to 0. So we have y equals to 3.2 raised to x plus 8. Okay? Let y equal to 0. Copy everything. Plus 8. Okay? Then combining like terms, it will become negative 8 on the other side. Copy 3.2 raised to x. So 8, if we will put 8 on an exponential form, it will be negative 2 raised to 3. Copy. So in this form, if you will try to analyze, there is no way that we can put or write the bases as equal bases. Okay? We cannot make 3.2 and negative 2 raised to 3 as the same basis. So we can conclude that since there's no way okay, since there is no way we can make their bases equal, therefore there is no x-intercept. Okay? Now let's proceed to y-intercept. So solving your y-intercept, x should be equal to 0. Then copying, we have y equals to 3.2 raised to x plus 8. And y equals to 3.2 raised to x equal to 0, then plus 8. Again, any number raised to 0 is equal to 1 plus 8. Therefore, y is equal to 9. So, the y-intercept is at point 0 and 9, or the graph will intersect your y-axis at point 0, 9. So I guess that you have learned something from this video. Please subscribe. Thank you so much.